Hi. Hi, everyone. Welcome to today's webinar. I'm just going to leave it a couple of seconds that more people can join. But welcome. Hello. If you missed this talk, this was part of the European Open Source Summit Yocto Developer Day. And Ed, who's below, who will say hi in a minute, he gave it. So we wanted to give us a chance to show it to everyone who didn't get to see it in person, because not everyone got to go to Amsterdam, right? I didn't, lucky Ed. So now we can all get a chance to see the glory of it. Just while we're waiting, I just want to talk a little bit about Wittekio. So if you've never been to a Wittekio webinar before, it is streamed across. You might be watching on LinkedIn, you could be on YouTube, you might be on Facebook or X, or on the platform that we use, which is StreamYard. So hello. Whichever platform you're on, if you ask your questions in the chat, I can see them. And then at the end, we'll have a live Q&A. So any questions you have, just put them down in the comments, and then I will ask them at the very end. So to get started, if you don't know who Wittekio are, I don't know how you don't know. I'm only joking. But basically, we're an embedded software application and connectivity partner. So we're a software services company. We are based in Paris, Lyon, Bristol, Seattle, Stuttgart. We're international, and we've been working for about 22 years, and we've got about 170 Wittekians. We're actually part of the Avnet family. Today we're talking all about Yocto, but we don't just do Yocto. We're obviously I call it chip to cloud. So we do everything from kind of low-level BSPs up to your embedded apps, your edge AI integration, connectivity, security, and we work with a lot of the biggest silicon vendors and hardware partners around. So if you have any questions, not just about this, but about other things, put them in the chat and I will give them to one of the engineers, or Ed might be able to answer them. If you're lucky, I'm sure he will. And just to let you know that we work across a host of industries. So today we're talking about kind of off-highway. We've also got some kind of home appliances, but we work across a range of industries. So I'm going to stop talking and I will be watching all your comments, but I'm going to let Ed take the floor and present. So Ed, off you go.
Okay. Hi, everyone. Welcome to this talk I'm going to give you, where I'm going to talk about some lessons that we've learned in Wittekio whilst helping our customers deploy and develop Yocto into real devices. So all of the anecdotes I'm sharing today are coming from real developments for products that have actually shipped and are on the markets from our customers. So first of all, my name's Ed Langley, Solutions Manager in our Bristol office in the UK. Been with the company quite a few years, done various roles. Embedded software engineering is my background. But the important thing is that over all of that time that I've been at Wittekio, I've helped lots of customers with projects involving Yocto. And Wittekio as a whole has worked with many more customers than I've been involved with in Yocto and other software, but we're focusing on lessons learned working with Yocto today. So before we get into specific lessons, I'm just going to share a couple of lessons. I want to talk about how we've sort of come to see patterns of pitfalls that customers have fallen into. And that is largely because consultants have a sort of a unique perspective on the on embedded software industry as a whole, where we work with customers who often are largely all doing a very similar thing, which is to take some custom hardware, which in different cases more or less customized from a reference design usually. They want to put Yocto on it. They want to put a device application on it, which takes it from being an evaluation board or something that boots to a Linux shell prompt to actually being a working product. And then you've got to fix all of the niggling little problems with it and then ship it. And once their consumers have it in their hands or are working with that product, it needs to be maintained. Nowadays, it needs to be maintained with over-the-air updates and so on. And the analogy I often use for the way we work with customers is that I sort of view all these customers as sort of like strands in a wire, which is kind of what that picture is. They're all doing roughly the same thing, like I just said. They're all kind of going in the same direction towards their end goal of shipping and maintaining products. But they don't really have a chance to look across at each other and see what each other are doing. Whereas we, helping, a large variety of different customers, it's kind of like taking a cross section through that cable where we can have a peek into what each individual customer is doing and, where they're having problems. And that's when an interesting pattern starts to emerge over the years across the different projects, where I started to see a client would get stuck on a specific area of their development. And then on the next project with a different customer, that client B, would get stuck on a completely different thing. So, for example, had one customer where they were having real difficulty with their real-time clock, just managing the time in their RTC. And then on the next project, there was a customer, they were doing a battery-powered device, and they were having real problems with their power management and their battery charging. And the first project was battery-powered as well. So I went back to them and said, how did you guys get on with your battery management? And they said, absolutely fine, didn't have any issues with it whatsoever. And then I went to the second customer and I said, did you have any trouble with your real-time clock? And they go, no, what are you talking about? We never had any issues with that. It just worked out of the box. So it's an interesting pattern that different people, different teams of developers seem to get tripped up and make kind of a mountain out of a molehill with different issues. And obviously, the ideal situation would be if nobody had any issues with anything and the development was just really easy. So that's kind of the intention of talking through a few lessons today, is to sort of highlight where issues have come up that we've seen in common with a few different customers. Before I talk through the lessons, just want to talk through a couple of projects that some of these are drawn from, just to give you a bit more context. So this first example is an industrial product. It's from W.H. Leary. It goes on a it goes on a line and squirts glue onto packages to seal them up. The packages are whizzing past on a conveyor belt really fast, so there's some real-time processing requirements there. And the main point of this project was initially to port the hardware from running Windows CE over to using a Linux-based OS. So Yocto was the choice for that. And then all of the applications were ported from Windows CE to be Linux or POSIX based. I'm not going to go through every point on each of these examples. I'll just give you the main sort of requirement that we helped with. This is an example of a consumer product. It's a high-end consumer coffee machine. And this product, we ended up helping them with everything. So the OS, the board bring up all the way through the device application, the developments of the GUI and Qt, and also the maintenance, the long-term maintenance. So I'll come back to that in one of the lessons later. And here's an example of an off-highway product. So this is for an American tractor company. And in tractors nowadays, there's a lot of screens and displays, more so than in a regular consumer automobile. So each attachment that you can put onto your tractor to like plow, spray, sow seeds, etc. They all have a display, so you can control, how much you're feeding out, so that you can control your use of materials and save cost and be efficient. You can have the tractor drive itself as well. That's another screen. And the main thing that this customer was having trouble with, that we helped with, sort of ties into the first lesson that I want to talk about, and that is platforming. So let's say a customer has a product, product A in this diagram, and it's pretty well set up. They've got building the whole firmware image in Yocto. They've got all their device applications set up as recipes in their own product A meta layer there. They've got some other layers for their specific hardware, or over the top of the standard set of Yocto-based layers with open embedded and all the standard recipes in. And they've got their application and all their repos that are referenced by those recipes. Now, when they decide they need to make a new product, it needs to do new things, it needs new features to keep up with the marketplace. So they get some new hardware to achieve that from a different vendor. And in order to build something and get it running in the first instance, they'll go to the website of the vendor. It might be a SOM provider, it might be somebody who makes an evaluation board or something, and they'll go look at the downloads page for the software. What can I get for this to get it running on my desk? And they'll find some instructions to build Yocto. And typically the customer is more concerned with their market and developing the product than they are with best practices of Yocto. So what happens is they sort of view this as something else from product A. This is a new thing. So they end up with a whole separate build environment where they're building basically mostly the same stuff. It's most of the Yocto build is essentially the same, might be slightly different versions, but it's the same as product A, but it's all entirely separate. And then the same thing happens with subsequent products. And what happens then is when they make an improvement to one of their custom recipes for product A, they decide, well, that would be really good if we had the same thing in product B. So they end up copying and pasting their changes all the way from this entire set of repositories for product A all the way over to product B, and for product C as well, etc. And the problem is, much like when you are programming code, if you find that you're constantly thinking, oh, that's a good useful bit of code there, I'd like to use that over here. If you're copying and pasting that piece of code all over your code base, you're doing it wrong. You should be reusing it, right? And it's the same thing with all of your patches, the different packages to your recipes that you're creating. And to some extent to your application, device application might want some commonality from one product to the other. And then if you see product D there, which is running Ubuntu, oftentimes when a customer has sort of start to get a number of products in their portfolio, they'll end up with the odd, what I call the odd one outs. And I'll say, what's going on with this product? And they say, oh, yeah, that one's running Ubuntu. And I'll say, oh, nothing wrong with Ubuntu, but I'll say, you're running Yocto on all the other products. And you could get a meta layer for that product D hardware, that it's out there. And they say, oh, yeah, well, when we first got that bit of hardware and we wanted to run something on it on day one on our desk, we just went on the website and clicked on the downloads page, and there was an Ubuntu image, and there was no mention of Yocto. It was just the Ubuntu image. So we run Ubuntu on it, and that after that was a real conversation I've had with multiple customers. And after one time, that's when I coined the term the evaluation board approach to product development, where whatever they manage to get running on their evaluation board on day one seems to set the path for the entire product development for possibly years after that time, after that first day, where everything is dictated by what was available for download from the vendor's website in the very first instance. Now, the lesson and the best practice is to try and aim for something more like this, where you have one Yocto build environment, and it uses one common set of open embedded meta layers at the bottom there. And then you can have different layers that you can add depending on which products you're building for, that you can put, if you need to, you can put specific recipes for a given product in. But ideally, most of the recipes would all go in just a shared layer for all of your products. And you just have different image recipes to build a firmware image for a given product. And in doing that, that would allow you to reuse most of your patches and customizations to your rootfs, etc., for all of your different products. So if you change one, all you need to, that would change it for everything. All you need to do is just make sure you test that build on all of your different products. But it ensures maximum code reuse, maximum Linux rootfs customization reuse, and then adding products becomes much easier because there isn't this feeling that you're starting again all over. You're just adding to this platform. So when you see on sort of marketing speak slide, this line in the solution section that says modular platformized architecture supporting multiple system on chips, that's what we're talking about there. I'm talking about getting them onto a platform that they can then move from one of their display products through the whole product portfolio. And this allowed them to make all of their maintenance and development much more efficient. So that's the first lesson. The next lesson is based around upstream versus downstream. And what that means is upstream being closer to the bleeding edge of the development of a given project, the open source project, for example. So if you're using Yocto, it's an open source project. There's releases, there's long-term releases. Currently, most customers we see are using ScarfGap because it's the current long-term supported release. Now, as soon as you mention upstream, people suddenly think upstreaming, so contributing back to open source, which is a nice thing to do, and we all aspire to do it. However, there was this term coined by Tim Bird about 10 years ago called version gap, where most of us developing products to go onto the market and be sold, usually not working on mainline code, working on something that's been released and sort of patched for stability, which is some way behind mainline. And that's, for example, that's what ScarfGap is right now. There's subsequent releases coming out, which we're not far off the next long-term support at this point. And that's usually the best choice to pick. However, things can go the other way, where instead of getting too close to the latest mainline code, you pick a release to use at the start of a project. It might be a multi-year development. By the time you get to a finished product, if you haven't been keeping up with subsequent releases of Yocto, you're going to be very out of date. And if you checked your software bill of materials that you need to be generating, really, you might find that you have a lot of vulnerabilities to CVEs that have been discovered in the time since you picked that release up to start your development with. So you need to stay up to date in order to, avoid your product being insecure by the time you put it out onto the market. But if you get too up to date, then you end up with code that might still have a number of bugs in it because it's fairly fresh off the press from upstream. So the overall lesson, there's not necessarily a right or wrong answer to this, but the overall lesson is to try to stick with the latest long-term release and persuade your upper management to invest in making sure that is done through the product development. It might be seen as a bit of a lateral move because usually there's a push to keep developing features. It's like, no, we also need to stay up to date with what we're basing this product on, to avoid a big hurdle later when, if you're selling something that needs to be in a marketplace where some kind of security certification is needed, you end up with a huge hurdle to get through to get that certified. That's the worst case. I mean, also, you don't want your product to be seen as insecure in general. So the next lesson is focused on DevOps, essentially. So testing, I mentioned regression testing. Once you've created a platformized structure to support all of your products across, if you change one thing, and that automatically goes into a build for each of your products, you really need to have your testing very well set up so that you can easily regression test each of your products, ideally using automated testing. And when moving between Yocto releases, it's actually quite easy to update your Yocto release. You just change a bunch of branch names and fix up some build issues, some conflicts with your BB append files, etc. The work of doing that is regression testing that nothing is broken at runtime. And to do that, the ideal kind of dream test setup, CI/CD setup, is when you push some code, your repos, which might be cloud hosted, that might be locally hosted, trigger hooks in the CI server, or CI pipelines in your cloud hosted Git repos. You might be on Bitbucket or GitHub, etc. And either you spend a fortune on build minutes, or you have a local runner that does the build for you, and then that feeds into some automated testing system, which using what I've called a test controller framework in that diagram, runs some hardware in the loop testing on the device under test. So that's the dream scenario that we should, everyone aspires to, but not, sadly, in the real world, not everybody is doing, because it is quite a hurdle of efforts to get over to have that in place. Bigger companies accomplish this by hiring a vast test team of developers who are just developing tests and setting up and doing DevOps, etc. Not every company can do that if they don't have the time or the budget. So the lesson here is, rather than just thinking, well, it would be really good if we did that, but we can't do that, so we're just going to keep our 2 testers in the corner who just run the manual tests, and it takes 2 weeks or a month to do a full regression test suite on one of our just one of our products. The lesson is to just start small and work towards it gradually. So we have some test tools in Wittekio with the embedded kits. They develop a test framework called Pluma, which will control your device under test and allow your automated tests to, turn on and off the hardware, load things onto an SD card, etc. The various other things. But the lesson from that is that you can take that and just run it locally on your laptop, on your desk, have your hardware under test on the desk, and you really don't need a huge investment of time to set up all of your CI/CD, etc. You can just have get a very minimal setup going on the desk. So you can just run a command and it will say flash a new build onto your hardware and automatically do just a few checks on it, just as a starting point. Just check it boots up to a shell prompt. And that's so useful, because what it does is just allows you to get started. And once you've gotten started, then it's so much easier mentally to just add something to that over time. And then eventually you can put it on to the end of a CI/CD pipeline on Bitbucket or GitHub or whatever, or GitLab. So the lesson being, start small with some automated testing, and you will get there eventually. And the last lesson for today is about long-term support strategies. So if you're making a product that you wish to support for a given lifetime after somebody had bought it from you, the 2 main things you need to do really is identify, when do I need to release a new update, a software update for this device, and making sure that you can build that some way into the future. So some markets, some types of products for infrastructure, industrial critical infrastructure, you can be talking about a 20 years support lifetime. So you need to make sure that what you're building today, you can be building in 20 years time. And that is not a challenge that's unique to Yocto. And also, so how do you identify that you need, well, just a little slide on how you identify that you need an update. So again, this is becoming an example of a setup that's becoming quite necessary if you want to get past the CRA, etc. You need to be figuring out, or having ways of identifying when you have vulnerabilities, CVEs that have been filed, that are in your product version, your product firmware version that's out there now, and therefore an update is necessary. So that's, I mentioned software bill of materials earlier. Obviously testing, automated testing ties into this, and monitoring for CVEs in your build. So all of that encapsulated into another kind of DevOps pipeline, essentially. Once you've identified using something like this that you need an update, how do I build it in 20 years time? So this is the Yocto lesson, Yocto related lesson here. When customers, when production managers see all of this stuff getting pulled in by a Yocto build off of the internet, they're like, this is never going to work, in years to come when all these URLs or have just become dead links and stuff gets moved around on the internet. And what you need to do, what the lesson is to reassure them that, okay, the downloading of stuff, that's the Yocto specific challenge, but you can mitigate all of that. It's fairly easy to just get a setup where everything is mirrored locally. You can just put it on a big hard disk next to you. You can just do the whole build with everything as the versions are now, just offline. Yeah. All of the other challenges of building everything in 20 years time, the general advice for any project, that would be the same whether you're using Yocto or any other software to put into your product, any other build system. You still have to make sure you've reliably stored everything, make sure that you've got a build machine or virtual VM or something that you can run all your tooling on and store all of your tool chains if necessary. So that's just a little lesson in how to sort of reassure people that using Yocto does not prevent you from still being able to rebuild and reissue new software versions in decades to come if necessary. And so that is it. Just a small sharing platter of lessons for today. Dare I ask if we have any questions? Georgie?
I'm muted, sorry. We do have one, and I'm sure more might come in. Thank you, Ed. That was great. So one question, let me put it on the screen. This person actually had to drop, but we'll answer it so that he has the information for next time, if you can. He asked, what is the most used package manager with Yocto in production deployment? Do you know that, Ed?
Yes, because at the Yocto development day, end game, yeah, this is one of the quiz questions, which was, what is the default package manager in Yocto? So okay. Unless I'm assuming, I'm basing my answer on the assumption that people just use the default one usually, which is RPM. And that kind of caught a few people by surprise. A lot of people thought it was the IPK package, which is a very much more simpler version of RPM, but it still has dependencies. However, for most people, when they do a build of a rootfs for their products, their update strategy is to just update the whole image at once rather than updating anything in the image. And that's important for maintaining your software bill of materials to go with each firmware version you have. You really want to know exactly what's in that one firmware image. So you really don't want people to be able to update the contents in their device individually. You want to be able to control the whole build and issue a new build to your customers, so that you know if they're vulnerable to a given CVE, for example. So usually that means that there's no package management in the running image on devices inside products. So I'd say the most used package manager in the resulting image that Yocto builds is none, which is that's my own unique answer. It's still used internally when it's doing the build, but the end result is a rootfs with no package management in there.
Okay, so you've heard it straight from the developer day quiz. Thanks.
Yeah.
If there's no other questions, I'll leave a little minute for people to ask any other questions they have. But is there anything else of interest that the people watching from the that you got from the developer day? Anything that you were like, oh, this is interesting moving forward?
Lots of people interested in automated testing.
Yeah,
that remains a very popular topic at the Open Source Summit, but particularly at the Embedded Linux Conference track there. As soon as you mention it, automated testing, everyone's ears prick up about that. So.
Got you. So automated testing is the thing that we can hope will come out of the next, development and everything. Okay.
Yep.
If no one else has any other questions, we will leave Ed to get on with his lovely work and his coding. But thank you so much to everyone for joining. And if you do have other questions and you're watching this on repeat, because I know on LinkedIn or YouTube or wherever you're watching, it will come up after the fact. Feel free to continue to ask your questions and I will pass them to Ed and we will answer as soon as we can. So thank you so much, Ed. Thank you for your presentation and all of your knowledge today. And thank you to everyone for watching. Have a really good night, everyone, and a good morning if you're in America. Bye.
All right. Thanks, Georgie. Thanks, everyone.
Bye.